Hello, my dear students. Am I audible to everyone? Good evening. Good evening. This is your Sunando sir live once again with physics today. Welcome, my dear students. ICSE Class 10th students, ICSE 2025-26 batch. So I hope I'm clearly audible, clearly visible to everyone. Come on, tell me. Give your response in the live chat. Let me see if I'm clearly audible and visible to all of you. Good evening to everyone. Good evening to everyone. Today we will be doing a very important chapter. Light ka first chapter, refraction through plane surfaces. Competency based questions from refraction through plane surfaces. Not a very easy chapter. It's quite challenging. I have taken some challenging questions today and you all will enjoy doing these questions. You will be enjoying while solving these questions. The questions are of good standard. All right. So once again, a very, very good evening to all of you, my dear students. Your board exams are knocking at your door. Your board exams are knocking at your door. And is my voice cracking? Please confirm. I hope I am audible, clearly visible. Today I have selected very, very, very good questions, excellent questions. Okay, so let's get started. Now, if you remember, my dear students, in the previous live session that we did for physics, I said that there was one question from current electricity that we were still left. Okay, the PDF that we were using for doing the live session had one last question that we could not take up in the previous live, if you remember it. All right, so that question I will take up. I will take up that question first, and then I will jump to this light refraction through plane surfaces questions. So are we ready? Are we ready? Good enough to go? चलो start करते हैं. तो सबसे पहला वो क्वेश्चन जो करंट इलेक्ट्रिसिटी से था, जो क्वेश्चन मैंने तुम लोगों को बोला था कि वो मिस हो गया था प्रीवियस में. ठीक है, चलो शुरू करते हैं. एक सेकेंड रुको. एक मिनट. हाउ डू यू just a minute. Sound level is 50%. All right. So let us now first start with that question. I hope that question is visible on your screen at this moment. That particular question is visible on your screen. The question which we could not discuss in the previous live session. Let me tell all of you people that we are doing lives of physics and computer applications every alternate days. And in our previous live session, we could not do this question. This question was the only question that was left from that PDF that we were using. So here is that question. Come on, read the question. Try to do this. This is also a very, very good question. So I'm reading the question and you also try to solve it. All right. A circuit diagram is shown below. You can see the circuit diagram connected to a battery of 12 volt. So you can see the EMF of the battery is given 12 volt and internal resistance of 1 ohm. So it is also given that this battery has an internal resistance of 1 ohm. Very good. The circuit consists of two parallel branches. You can see in one of the branch 3 ohm and 3 ohm are connected in series, whereas in the next branch you have 2 ohm and another 4 ohm connected in series. So these are the two branches. All right. And what does it say? The circuit is completed by a key K. So you can see there's a key K. Okay. Now what do we have to find? We have to calculate the resistance of the circuit when the key K completes the circuit. So when the key K completes the circuit, it means that we have to also consider this internal resistance while we are calculating the total resistance of the circuit. So it's very simple. Very simple. You have a 3 ohm plus 3 ohm over here, that is a 6 ohm, because 3 and 3 are in series, so that 6 ohm adds up. 4 plus 2 is again 6 ohm. So basically 6 ohm and 6 ohm in parallel, and to that you have the entire thing is in series with 1 ohm. The entire thing is in series with 1 ohm. So what is the total resistance of this circuit, they have asked. So let us now first calculate the external resistance. First of all, I will calculate the external resistance, and to that I will add the internal resistance. So Rx we are calling it. What is it? It is 1 upon 6 plus 1 upon 6. So this is 6, this is 6. So 1 upon 6 by 1 upon 6, that gives you 2 upon 6, and that is 1 upon 3. Alright, so our external is nothing but 3 ohm. That means this is 3 ohm. This is 3 ohm. This whole setup is 3 ohm. Absolutely correct. And here you have a 1 ohm. So this 3 ohm and this 1 ohm, they add up and we get the total resistance. The internal resistance is 1 ohm. So we have to calculate total resistance. Total resistance we have to calculate, and total resistance is given by R total, which is equal to this 3 ohm plus this internal resistance 1 ohm. So that is 4 ohm. So I could see many of you have already given the answer 4 ohm, and that is absolutely correct. Now part B has asked us calculate the current in 4 ohm resistor. Now here you need to be very, very careful, extremely careful. We have to find the current in 4 ohm resistor. Let us find the total current first of all. And do you remember, I have told you this formula, we have used this formula for finding the total current, EMF upon R total. We have used this so many times in our previous live session also, right? I hope you remember it. So total current हम निकाल रहे हैं, EMF है 12 and R total है 4. So 4 3s are 12, so 3 ampere. So total current is 3 ampere. Total current is 3 ampere. Now when this 3 ampere reaches at this point, which I have marked with blue, reaches at this point, this 3 ampere splits into 2 parts. Say I1 and I2, it splits into 2 parts. Now in what ratio will it split? If you see both of the paths, each of the branches have the same resistance. This is also 6 ohm, 3 plus 3, and this is also 6 ohm, 4 plus 2. So 6 ohm and 6 ohm means 50-50 equal parts में वो divide हो जाएगा. ऊपर में भी 6 ohm है, नीचे भी 6 ohm है, तो ये जो 3 एम्पियर करंट है ये 50-50 आधा आधा डिवाइड हो जाएगा. तो इस रास्ते से 1.3 का आधा क्या होता है? 1.5 एम्पियर गुजरेगा, नीचे वाले ब्रांच से भी 1.5 एम्पियर गुजरेगा. हमें पूछा है 4 ओम से कितना करंट जाएगा, तो 1.5 एम्पियर ओनली फ्लोज थ्रू 2 ओम ऑल्सो, एंड द सेम करंट flows through 4 ohm also. Not a very difficult thing to understand. It's very simple. The series में the same current flows. So 2 ohm से जो current जाएगा 4 ohm से भी वही जाएगा. Therefore what you can write, current through 4 ohm is equal to 3 ampere का आधा, that is 1.5 ampere. And 1 or 2 students have already answered it. I can see that the answer is 1.5 ampere, and that was absolutely correct. Now the third part, who can say the answer to the third part? Calculate the potential difference across 2 ohm resistor. Who can answer this? Calculate the potential difference across 2 ohm resistor. I could see one child, Preetham, has replied 3 volts. Is there anyone else who wants to try, who wants to answer that what is the potential difference across 2 ohm, and how many of you agree with what Preetham has said? Is it 3 volt? यहाँ पे 2 ohm जो resistor है इसके across कितना potential difference है ये हमें निकालना है. तो potential difference का formula होता है V is equal to IR. ये I क्या है? The current that is entering into 2 ohm. ये R क्या है? R है ये 2 ohm खुद, क्योंकि 2 ohm के across हम निकाल रहे हैं. तो V is equal to IR से हम potential difference across 2 ohm आराम से निकाल सकते हैं. So क्या लिखेंगे? Potential difference across 2 ohm is equal to IR. जिसमें I कितना है, जो करंट फ्लो कर रहा है उस रेजिस्टेंस से, विच इज 1.5 एम्पियर। इस याद रखना 1.5 एम्पियर ले रहे हैं हम, टोटल करंट 3 एम्पियर नहीं लेंगे, क्योंकि हमें वो करंट लेना है जो 2 ओम से पास कर रहा है। सो 2 ओम से 1.5 एम्पियर जा रहा है एंड रेजिस्टेंस का वैल्यू तो 2 है। सो 1.5 इंटू 2 इज 3। सो 3 वोल्ट इज द पोटेंशियल डिफरेंस अक्रॉस 2 ohm resistance. Is this clear to all of you? Has everyone understood this? If you have understood this, you can press the heart button couple of times and give a momentum to this live session. If you have really understood how have we solved this. Now we will be starting with refraction through a plane surfaces. So we move directly to that particular this thing. PDF. All right. I hope you are enjoying. You have understood everyone. So now we are going to start with light refraction through plane surfaces. So here is the first question. We are doing regularly live sessions on physics and computer applications. So here is our live session today for light, first part of the chapter of the unit. That is refraction through plane surfaces. Now read the question. Read the question. What does the question tell? The question says, a ray of monochromatic light of wavelength lambda naught in air enters a water tank of refractive index. The water ka refractive index is given 4/3. We have to calculate the wavelength of light inside water. बहुत ही इजी क्वेश्चन है, एक डायरेक्ट फॉर्मूला बेस्ड क्वेश्चन है। क्या कहता है कि एक लाइट रे है मोनोक्रोमैटिक, मोनोक्रोमैटिक मतलब सिंगल कलर का लाइट रे है, सिंगल कलर का लाइट रे है जिसका वेवलेंथ लैम्डा नॉट है एयर में। जब वो लाइट एयर में मूव कर रहा है उस लाइट रे का वेवलेंथ है लैम्डा नॉट। लेकिन जब वो वाटर में एंटर किया तो वाटर का रिफ्रैक्टिव इंडेक्स 4/3 है। तो वाटर में जाके उस लाइट रे का वेवलेंथ क्या हो जाएगा? कैलकुलेट द वेवलेंथ ऑफ द लाइट रे इनसाइड वाटर। तो सबसे पहले तो ये बात है कि वाटर में जाके उसका वेवलेंथ चेंज होगा कि नहीं होगा, दैट्स द क्वेश्चन। यस, चेंज होगा। जब भी मीडियम चेंज हो जाता है तो वेवलेंथ भी चेंज हो जाता है। जब वो रेयरर से डेंसर में जाता है, रेयरर से, if you don't know this and if you want to note it down, you can note it down. When a light ray moves from rarer to denser medium, then what happens? Its speed decreases and wavelength also decreases. Wavelength also decreases. And the reverse thing happens if it happens the other way. Denser to rarer जब वो जाता है तब उसका स्पीड इंक्रीज करता है और वेवलेंथ भी इंक्रीज करता है। Wavelength also increases. So the first question, if it is moving from air to water, means its wavelength should decrease because it is moving from rarer to denser medium. तो क्या फॉर्मूला है? तुम लोगों ने इसको पढ़ा था ना कि लैम्बडा मतलब वेवलेंथ ऑफ द लाइट इन अ मीडियम इज इक्वल टू वेवलेंथ ऑफ द लाइट इन एयर डिवाइडेड बाय रिफ्रैक्टिव इंडेक्स of the medium. In this case it is the refractive index of water. Have you seen this formula earlier? This is a very useful formula. In previous year board also they had asked this question. So lambda naught, इसको lambda naught के terms में ही हम आंसर करेंगे। 4/3, so this 3 goes up, so it is 3/4 of lambda naught. This is the answer. इसको तुम चाहो तो डेसिमल में कर सकते हो, 0.75 lambda naught. This is the wavelength of the light inside water. Second बोल रहा है, क्या बोल रहा है? If the frequency of the light in air is f naught, what is the frequency of the light in water? This is simple. What would happen to the frequency of light? Should it change when light ray moves from one medium to another? Frequency does not change. Are you aware of this? When a light ray moves from one medium to another, the frequency does not change, it remains constant. So you will see what is the frequency of water. So frequency in water, so frequency of the light in water is equal to frequency of light in air बिकॉज इट डज नॉट चेंज एट ऑल. सो एयर में उसका फ्रीक्वेंसी एफ नॉट है, तो वाटर में भी एफ नॉट होगा. एक्सप्लेन करोगे क्योंकि यहाँ लिखा हुआ है एक्सप्लेन करना, दैट देयरफॉर यू नीड टू एक्सप्लेन ऑल्सो. सॉरी, therefore you need to explain also. So you will explain, explanation, you can write explanation. What will you write? Frequency of light depends on the source, not on medium. Very good. So here we are done with the first question. Now coming to the second question. A ray of light is incident 30 degrees to the normal on a rectangular glass slab of refractive index 1.5. And one angle ka sine is given. Sine 19.47 degrees is 0.33. God knows why this is given, but you will realize it later that why this value is given. Now, how calculate the angle of refraction inside the glass slab? So, हमें angle of incidence दिया हुआ है. Very simple question. We know the angle of incidence is 30 degrees. It is given. And हमें क्या निकालना है? Angle of refraction हमें निकालना है. We don't know. And we know the refractive index of the glass. We know it. It is 1.5. So, using Snell's law, we know that refractive index is sine I upon sine R. You know this? Everyone knows this. The refractive index is sine I by sine R. Refractive index is given. That means 1.5 is sine I का value 30 degree. Sine 30 degree upon sine R. तो sine R का value क्या हो जाएगा? Sine 30 का value क्या होता है? 0.5 होता है. Half होता है, right? Upon 1.5 हो गया. तो sine 30 का value 0.5, नीचे है 1.5. तो साइन आर का वैल्यू, इसको सॉल्व करोगे तो साइन आर का वैल्यू, इसको सॉल्व करोगे तो 0.3333 आ रहा है. एंड इट इज गिवन कि साइन 19.47 इज 0.33. दैट मीन्स इज आर का वैल्यू 19.47 डिग्रीज है. इट इज गिवन. तो गिवन डेटा इसीलिए दिया हुआ था ताकि हमें सॉल्व करने में आसानी हो. तो देयरफॉर आर इज इक्वल टू 19.47 डिग्रीज, ये हमें मिल गया. Now this is the first part of the question. Now the second part of the question is asking how would the lateral displacement change if the thickness of the slab increases. Now it's a direct question. It's a very direct question from the book, from the topic factors affecting lateral displacement. So factors affecting lateral displacement में तुम लोगों ने पढ़ा होगा कि thickness of the slab अगर increase करता है तो lateral displacement भी increase करता है. एकदम सिंपल सा बात है. lateral displacement भी increase करता है. So if lateral displacement कैसा change होगा? If thickness of the slab increases, you will write the lateral displacement also increases. Very simple. The lateral displacement also increases. The lateral displacement also increases if the thickness of the slab increases. Come on, note it down. It's a very, very easy question. I hope you have understood everyone. Okay, let's move to the third question. Now, what is the third question? What is the third question? Yes, correct. What is the third question? A glass air boundary has a critical angle of 42 degrees. So critical angle का value दिया हुआ है 42 degrees. A light ray traveling in glass approaches the boundary with an angle of incidence 50 degrees. Now see, critical angle is 42 degrees and angle of incidence is 50 degrees. तो यहाँ पे angle of incidence is more than critical angle. ऐसा कभी भी होता है, तुम्हें पता होगा, if you have studied it, it's a very easy thing. अगर angle of incidence critical angle से ज़्यादा हो तो what phenomenon will occur? Can you answer this? What phenomenon will occur? Very good. Total internal, you all know it. Total internal reflection. Total internal reflection will occur. Explain briefly बोला है तो बोलोगे when light ray, मतलब total internal reflection का definition ही लिख दो. when light ray is traveling from denser to rarer medium, and if its angle of incidence is more than critical angle for the given pair of media, then total internal reflection occurs. ऐसे लिखना होगा तुम्हें रीजन, क्योंकि यहाँ पूछा है explain then only. Now the second question is, if instead the ray inside the glass had an angle of incidence 40 degrees, what would have happened? अगर 40 degrees होता तो क्या होता? तो 40 degrees होता तो it is less than 42 हो जाता, means angle of incidence would have been less than critical angle, और उस केस में क्या होता है? टोटल रिफ्लेक्शन नहीं होता है, पार्शियल रिफ्लेक्शन एंड पार्शियल रिफ्रैक्शन होता है. तो वी विल राइट पार्शियल reflection and Raj Kaushal, are you solving the questions? Partial reflection and refraction. Okay, this is part B. Now coming to part C of the question, what does part C tell? Name one practical application of the phenomenon when the angle of incidence is 50 degrees. तो जब angle of incidence 50 degrees था, यानी जब total internal reflection हुआ था, तो उसका एक practical application बताओ. It's very simple. You all know that the data, the information through the optical fibers actually flow through this total internal reflection mechanism. Yes, very good. Transfer of data through optical fiber cables. Very good. Who said that? Obsessed person. Very good. That's the answer. In transmission of data through optical fiber cables. Absolutely right. So after you have noted it down, I hope you all have done it. Now let's move to the next question. It's a very, again, simple question. Try to do this. See, solving this question along with me will help you out a lot. You know that light unit has the maximum weightage of marks. Sometimes, 28 to 30 marks come alone from light unit. Maximum marks. Okay, 20 to 30 marks sometimes ranges between this unit only. And we are doing the first chapter of light unit, refraction through plane surfaces. So, this is a very important session for everyone, those who are attending it. So, very seriously try to solve each of the questions. A fish is at the bottom of a rectangular aquarium at real depth of 60 centimeters from the water surface. तो फिश का जो रियल डेप्थ है वो है 60 सेंटीमीटर्स. द रिफ्रैक्टिव इंडेक्स ऑफ वाटर इज 4/3. अ पर्सन स्टैंडिंग नियर द एक्वेरियम लुक्स वर्टिकली डाउन, नीचे देखता है. व्हाट इज द अपेरेंट डेप्थ ऑफ द फिश? वेरी सिंपल क्वेश्चन. द फॉर्मूला बेस्ड क्वेश्चन. व्हाट इज द फॉर्मूला? यस, जिसने 45 सेंटीमीटर बोला वो बहुत अच्छा. यस, आई कुड सी फ्यू स्टूडेंट्स हैव आंसर्ड. प्रीतम, आयुष, व्हाई डिड यू इरेज इट? Your answer was correct. Apparent depth is equal to real depth upon refractive index. So यहाँ पे हमें apparent depth निकालना है और real depth दिया हुआ है 60, ये है, और नीचे है mu का value 4/3. So this 3 goes up. So it is, okay, what is it? 12 3s are 4 3s are 3 2s are 6. No. 15, right? 15 3s are 45 centimeters. Yes, very good. This is the formula. So it's a simple question. 45 centimeter from the surface of the aquarium water surface. So the apparent depth is 45 centimeters. Very easy question. Okay, now the fifth question. Come on, let's do this fifth question. Let's do this fifth question. Suppose you have two transparent slabs. Yes, thank you everyone. Those who are enjoying the session and smashing the heart button. God bless everyone, and you all will get great marks if you are studying in this way sincerely. Excellent marks in your ICSE board exams. So don't get nervous. Just enjoy learning, enjoy your preparation with a cool mind, with a strong mind, positive mind. Keep doing your studies. Let's move to this question. What is this? Suppose you have two transparent slabs. One of crown glass whose refractive index is 1.52 with respect to air, and the another of some exotic medium, say its refractive index is 1.33 with respect to air. A ray in air is incident as 45 degrees on each of them. Using Snell's law, state qualitatively. Now qualitatively means you don't have to show any calculation. You don't have to show any calculation. You have to just see the values and tell which medium causes greater deviation. That means greater bending of the ray. Which medium would cause a greater deviation? Can you tell me whether it is crown glass or whether it is that exotic medium which will cause greater deviation? देखो बहुत सिंपल सा एक चीज दिमाग में सेट कर लो कि अगर रिफ्रैक्टिव इंडेक्स ज्यादा तो मतलब कि रिफ्रैक्शन ज्यादा मतलब बेंडिंग ज्यादा, बेंडिंग भी ज्यादा होगा. जितना ज्यादा रिफ्रैक्टिव इंडेक्स होगा उस मीडियम में उतना ज्यादा बेंडिंग होगा. एकदम सिंपल सा आंसर है. तो क्राउन ग्लास का रिफ्रैक्टिव इंडेक्स ज्यादा मतलब क्राउन ग्लास में ज्यादा ग्रेटर बेंडिंग होगा. एकदम सिंपल. तो यहां पे लिखो क्राउन ग्लास. ये लॉजिक दिमाग में सेट कर लो. क्राउन ग्लास यस विल कॉज ग्रेटर डेविएशन. नाउ यहां पे देखो ये स्लैब के बारे में बात कर रहा है क्वेश्चन. स्लैब इज ऑलवेज like this where the two sides are opposite sides are parallel. याद रखना स्लैब में ये अंडरस्टूड होता है कि ऑपोजिट जो साइड्स है वो पैरेलल होता है. रेक्टेंगुलर स्लैब की बात करते हैं. जब स्लैब की बोल रहे हैं तो अंडरस्टूड है कि वी आर टॉकिंग अबाउट द रेक्टेंगुलर स्लैब. नाउ क्या बोल रहा है बी क्वेश्चन. इफ द सेम रे पासेस फ्रॉम ईच मीडियम बैक टू द एयर, मतलब कि ये क्राउन ग्लास वाला रेक्टेंगुलर स्लैब है और दूसरा एक्सोटिक मीडियम से बना हुआ. कोई एक्सोटिक मीन्स इट इज मेड अप ऑफ सम कॉस्टली मीडियम. तो दोनों का रिफ्रैक्टिव इंडेक्स इज डिफरेंट. बट बोल रहा है विल द इमर्जेंट रे इन बोथ केसेस इमर्ज इन ओरिजिनल डायरेक्शन दैट इज पैरेलल टू इंसिडेंट रे. व्हाट डू यू थिंक? क्या दोनों केसेस में जो इमर्जेंट रे होगा वो इंसिडेंट रे के साथ पैरेलल में होगा क्या दोनों केसेस में? What do you think so? Of course yes. Because this does not depend on the medium, on the material of the medium. It rather depends only on whether the opposite sides are parallel or not. तो दोनों केसेस में तो ये स्लैब ही है, पैरेलल ही है. तो इसीलिए दोनों केसेस में ये जो है इंसिडेंट रे के साथ इमर्जेंट रे पैरेलल ही होगा. Yes, because it does not depend on material of the prism of the slab or medium, you can say material of the medium, rather it depends on whether the opposite, या फिर ऐसे लिख सकते हो, it depends on whether the surface of incidence, जिस surface पर incident ray गिर रहा है, whether the surface of incidence and the surface of emergence, जहां से emergent ray निकल रहा है उसको कहते हैं surface of emergence, are parallel or not. That is it. Okay, parallel or not. Let's move to the next bit. Now this is an assertion reasoning question. All of you will try. There are four options. Assertion is true, reason is true, but it does not explain. Assertion is true, and reason explains the assertion. Assertion is false, reason is true. Assertion is true, reason is false. Now, out of the four options, come on, tell me which option do you think is correct in this case? What is the statement telling us? When light ray passes from air to glass, its frequency decreases. Its frequency decreases. तो ये तो गलत बात है ना. Frequency we have just discussed earlier in one of the questions. Frequency remains unchanged. So this is a false statement for sure. And what is it telling? The next, the speed of light is less inside glass than in air. Of course, yes. क्योंकि glass is a denser medium. तो air से जब glass में आएगा तो उसका speed और wavelength दोनों decrease करता है. So it is obviously less. So this is true. Yes, you can say, may all of you have answered correct, that assertion is false, reason is true. Very good, very good. You all are able to answer correct. Let's move to the next question. So keep in your mind that frequency does not change when light ray moves from one medium to another. Only what changes? The speed changes, the wavelength changes. Okay, now question number 7. What is the question 7? A medium of higher refractive index always slows down light to a greater extent. This is assertion. Refractive index of a medium depends on the density of the medium. Does it so? Is it so? Does it depend on the density? What do you think? See, first statement is correct. Why it is correct? How many of you think that it is correct? Because refractive index of a medium of higher refractive index, I just told you a couple of minutes ago that higher refractive index means more bending, more of refraction will happen, more bending of light. And more bending का मतलब ही है more bending towards the normal actually, more bending towards normal, to be more clear. So more bending towards normal means it always slows down, क्योंकि slow down होने पर ही तो वो towards the normal bend करता है. So that means this first statement, the assertion is absolutely true. लेकिन refractive index does not depend on density. Density means mass per unit volume density. No, refractive index depends on optical density. अगर यहाँ पे optical density होता तो correct होता. देखो, optical density अलग होता है, physical density अलग होता है. जब सिर्फ density लिखा हुआ है, इसका मतलब physical density को मीन किया जा रहा है, वो अलग ही concept है. So physical density is mass per unit volume, and इसके ऊपर यही density का formula तुम लोगों को पढ़ाते आ रहे हैं. Since class 6, you know that density means mass per unit volume. But in case of light, when we are talking about rarer and denser medium, that denser does not mean that density. It means optical density, which is completely a different concept and which you have not studied at all. You just have used the word denser, rarer, but you don't know what is optical density. So this statement is false. It does not depend on density. It depends on optical density. Okay, now let's move to, so what will you say in question 7? Assertion is true, reason is false. That is it. Question number 8, we will do 10 questions today. We will pick up 10 questions today in this live session. Okay, so that you don't burn out yourself, because we are having lives every day, and lives every day, you also have to study other subjects. So we will have smaller, sweet lives, interesting lives. Will not, your energy should not burn out. So 10 questions we will take up. Small lives will have half an hour or so. So 8th question, come on, tell me. Total internal reflection cannot occur when a ray passes from air to glass. What do you think about it? Total internal reflection cannot occur when a ray passes from air to glass. What do you think about it? Is it true? Total internal reflection cannot occur when a ray passes from air to glass. Critical angle exists only for rays moving from denser to rarer medium. Yes, Preetham, your answer is correct. Ayush, try again. See, assertion is absolutely correct, because total internal reflection will happen only when a light ray is passing from denser to rarer medium. But here it says air to glass. So air is rarer, glass is denser. So it cannot happen, and that is written that it cannot occur. So this statement is absolutely true. And critical angle also is only, a topic, a concept that exists only when a light ray is trying to move from denser to rarer medium. Because only then a total internal reflection would occur if the angle of incidence is more than critical angle. So when a light ray is moving from denser to rarer medium, only then the critical angle would exist. So even this is true, and since this is true, total internal reflection cannot happen for a light ray passing from rarer to denser medium. So that means it even explains the reason, it explains the assertion. So both are true, 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 and it also explains. Great. The 9th question for you all. Okay, this is also an assertion reasoning question. Come on, try this. Come on, try this. When a glass slab of refractive index 1.6 is replaced by water whose refractive index is 1.33, the apparent depth of the object increases. What do you think? What do you think? Read the statement, assertion from again. Try to understand what is it trying to convey and what is the reason. Is the reason correct? Explanation of assertion. What is it? Try. When a glass slab of refractive index 1.33 is replaced by water whose refractive index is refractive index of 1.6 is replaced by 1.33, what will happen to apparent depth? Will it increase? It says increases. Is it true? So we have to think of the formula. What formula? Mu is equal to real depth upon apparent depth. You all know this formula. We have used this just a few minutes ago in one of the questions. तो यहाँ clearly दिख रहा है कि अगर mu increase करेगा तो apparent depth decrease करेगा. Both are inversely proportional. तो mu बढ़ेगा तो apparent depth घटेगा. Also the other way we can say if mu decreases apparent depth increases. तो वही तो लिखा हुआ है कि अगर हमने mu को 1.6 से 1.33 बना दिया, means if we have decreased the mu, then apparent depth will increase, and that's absolutely true from the given equation. R क्या कहता है? Lower refractive index. Lower refractive index means if mu is small, then this ratio real depth apparent depth will also be small, and that is also true, and it also explains this assertion. So yes, assertion is true, reason is true, and it also explains the assertion. Come on, are you people understanding this? Are you all understanding this? Today the energy seems to be a little low. I hope you are all writing also at the same time. You are understanding and writing it down also. All right? Yes. Now the 10th question and the final question. The 10th question and the final question. And we will take up more questions in the upcoming live sessions. We are doing the live sessions regularly. Okay. So don't worry about the leftover questions. We'll take up in the upcoming class. Yes. Now 10th question. When a light enters a denser medium, its frequency remains constant. What is it? True or false? True or false? And reason, frequency depends on medium while wavelength remains unchanged. What is it? What is this? Come on, tell me. So of course you see, yes, A is true. Ayush has said A is true, and this is correct because frequency remains constant. This I have been telling you since a long time, that light, whether it enters a denser medium or it enters a rarer medium, frequency will not change. So this is true. Frequency remains constant. बट यहाँ लिखा हुआ है नेक्स्ट में फ्रीक्वेंसी डिपेंड्स ऑन मीडियम, जो कि गलत है. फ्रीक्वेंसी डज नॉट डिपेंड ऑन मीडियम, इट डिपेंड्स ऑन सोर्स. और यहाँ लिख दिया वेवलेंथ रिमेन्स अनचेंज्ड. नो, वेवलेंथ चेंजेस when the medium changes. So this is false. So what it would be? Assertion is true, reason is false. So you see this PDF that I am using has a lot more questions, but I will be taking up these questions again in the next upcoming physics live. Tomorrow we have computer live session. All right. So seeing you tomorrow, computer live session at 7:15 p.m. You all have done a great job today, and now please smash the heart button as many times as you want so that it boosts up my spirit. So subscribe to this channel if you haven't done it yet for daily ICSE live sessions, and let's score 95 plus together. God bless you. Take care. Good night and study well. Jai Hind.